Welcome friends on the 13th lecture of elective 1, that is Internet of Things. We are learning now sensors and network chapter. So before starting with this lecture, I am going to elaborate what we have learned in the last lecture. So we started with magnetometer sensor in the last lecture. So we have learned about details about magnetometer sensor and how you are going to interface that magnetometer sensors with microcontroller unit and Arduino unit. We have learned that thing. Then after that we have seen different types of servo motors. We have seen different types of stepper motors, unipolar stepper motor, bipolar stepper motor, interfacing of those stepper motors with Arduino. What is the coding sequence we used for interfacing of stepper motor with Arduino. Then we have seen about servo motor, how we can have pass the angle for the servo motor and how the servo motors rotates with that particular angle. So we have seen that thing in the last lecture. So now we'll proceed with the next lecture, that is lecture number 13, that is sensors and network. So first in this lecture we will see about DST11, that is temperature sensor, temperature and humidity sensor interfacing with Arduino. So DST11 is a digital temperature and humidity sensor. So this is a module available. So I have interfacing diagram of DST11, that is temperature humidity sensor with Arduino interfacing. So here I have connected plus 5 volt to the plus 5 VCC of this particular module. There is a data pin, that is a data output available. So this is I2C bus data output, digital output. So I have connected to a pin number 3 and the ground pin is there. So that ground pin is connected to a ground. So the connection diagram is this. So one data pin is there, then plus VCC and a ground is connected. Okay. And we have here Arduino Uno and DST11 has been interfaced. Okay, so we'll see now in detail what is that DST11 sensor and how you are going to interface the DST11 sensor with the microcontroller. So DST11 measures the relative humidity. So DST11 sensor measures the relative humidity. So relative humidity, for measuring the relative humidity, we need to use this DST11. So relative humidity is the amount of what is actually a relative humidity. So relative humidity is the amount of water vapor in a air versus the saturation point of a water vapor in a air. So it is the amount of water vapor. So it is amount of water vapor in the air versus the saturation point of a water vapor in the air. So we need to look for saturation point of water vapor and amount of water vapor in the air. So actually humidity is in the terms of water vapor present in that particular air. Okay. At the saturation point, the water vapor starts condense and accumulate the surface forming dew. So at the condense point, it produces the dew and water vapor starts condensing. Okay. Then normal range of relative humidity is 20 to 90 RH. So it is measured in RH and the accuracy is plus minus 5%. Okay. So accuracy is plus minus 5% and normal range of a temperature is 0 to 50 degrees centigrade that DST11 supports, and the accuracy of this is plus minus 2% per degree centigrade as well, and the operating voltage range is 3 volt to 5.5 volt. So it operates with 3 volt to 5.5 volt. Okay, so this is about DST11 temperature humidity sensor. Okay. So this is the code for DST11 temperature humidity sensor, how you are going to write the code for this. So we have here hash include dst.h. So this is the header file we need to download from the GitHub. Again, on a GitHub we have a repository and it is actually a digital sensor. So we need to send some commands for that sensor and then that sensor will retrieve the data into a digital format. So we need to read the digital packets and based on that digital packets, we need to predict what is the humidity and where the temperature is located. Okay, so here for that purpose we have used this line hash include dst.h. Then we need to create one object of this. So I have created an object dst with a capital letter dst. If you requires to change the pin number, we can change the pin number. So here I have connected in the physical connection in this particular connection diagram. I have connected this data pin to the pin number 3. That's why In this particular slide, we have defined has defined DST 11 underscore pin is a 3. So whichever pin you are connecting that DST 11 data pin, that we need to define here. So has defined DST 11 underscore pin is equals to 3. Then we are going to print the output on the serial window. That's why the code is written void setup. Here it is, code is written void setup serial dot begin. So it is a serial communication begin line. So it will begin with 9600 baud rate. Okay, serial dot begin 9600 baud rate and serial dot println. So it's going to print on a first line. LN stands for new line, humidity and temperature detector. So it's print the message like humidity and temperature detector on a first line. Then under a while loop it is a while one again. So same as a while one. So we are going to read the data from the DST11. So how to read it? So we read that data into CHK. So dst.read11 is the function. This function is defined under this particular file. So this file is used for this particular function, and we pass the pin number for that as an argument. So we pass it here a 3 as an argument. So why? Because we have attached DST11 to pin number 3. That's why we are passing here 3 number as an argument. Then it will read that and it will pass it to the CHK data. So again it's going to print the message on a screen, that is humidity, and then dst.humidity and a 1. So this line will print the humidity on a particular serial window. Again we print the message as a temperature, and we'll print the serial.println dst.temperature and a 1 again, and delay for 2 seconds. So for every 2 seconds is going to print humidity and a temperature on a console. Alright, so this is about DST11 code. So how actually timing diagram works, we will see. Here it is a DST11 with a Raspberry Pi. So we can interface again with the Raspberry Pi as well. So again plus VCC, ground and the data pin. So what is the code, how we can write the code? So there are again 2 ways we can write the code. Either you can write in a Python or we can use in a wiring Pi as well. Okay, so again DST11 measures the relative humidity. Okay, the relative humidity is the amount of water vapor in the air. So this we have discussed this already. Okay, then this is the range. We have already discussed this range. Humidity range is 20 to 90% RH. It is measured in RH. It is relative humidity. Plus minus 5% accuracy, and 0 to 50 degrees centigrade temperature range. Plus minus 2% of accuracy of this, and it operates with operating voltage range of 3 volt to 5.5 volt. Just we have discussed this already. Here it is a pin diagram, and on the bottom hand side and the back side it is mentioned all the things. An internal structure of DST11. Here it is a DST11 module, and the only IC or only DST11 without this controlling module. These are the 4 pins, and we have here NA DST11. Operating DC voltage is 3.3 volt to 5.5 volt. Humidity is 20 to 95 RH. Degree centigrade 0 to 50 degrees centigrade. Accuracy is plus minus 5% RH and plus minus 2% degree centigrade. Okay, and the serial number of that particular module has been mentioned, and this module is a song. So manufacturer of this particular module is AO Song. Alright, so here it is a timing diagram, reading data and wiring diagram of this particular thing. So here we have connected this data to the GPIO 4, and VCC as a ground is connected. VCC is connected to plus 5 of Raspberry Pi, and the ground is connected to the ground signal line of a Raspberry Pi. Here we have a VDD and the ground signal. The first thing is host to start off a signal. So we need to send a start off signal, then pull up for wait, and then the response of the signal from the DST11, pull the radio output signal, and then the data will be written. Okay, so this is the data bit 1 to 8. You will get 8 bit of a data for each particular segment. Like for a humidity there is a 8 bit of a data, for a temperature again 8 bit of a data is available with this particular DST11. Alright, so this is about DST11 sensors. So here is the library. Again you can download the library from GitHub, that is Adafruit library available. So I have given a link here, github.com/adafruit/adafruit Python DST library. So you need to go to that particular root directory cd adafruit DST, where you have already installed the library. Then you can open the code like sudo python setup.py and install this particular library. Okay, so there is a command for installation on the Raspberry Pi, the Python library. This command is sudo python setup.py install. So once it is installed, you need to open sudo nano dst11.py and then compile it. So for opening this, the command is sudo nano dst11.py, and for compiling the command is sudo python dst11.py. Then it's going to print the temperature and humidity on a console itself. So here it is a output. Like this, you will get output like temperature 27.0 degrees centigrade and humidity is 73.0. Okay, so you can observe the code. So in this Python code, what is written? So it is written that import sys. So it imports the system file, it imports the Adafruit DST header file, okay, by using the command import Adafruit_DST, and it imports the time as well, while true, so it's while on. Then there are two arguments it returns. One is humidity, another is the temperature, and the function is Adafruit_DST dot read entry 11,4. Okay, so here it is the pin number we are passing, and type of a DST. So whether you are using DST 11, so we need to pass here 11. Whether you are using DST 22, we need to pass here 22, and the 4 is the pin number, okay, as the second argument as a 4 number. Then it's going to print the output on a console, that print temperature, then with the 0.1 degree accuracy, humidity again with a 0.1 degree accuracy, and the format we are passing that as a temperature as a one argument. For this, from here it takes the temperature, and humidity from here it takes the humidity. So like this, it's going to print humidity and a temperature on a console. Again, after that, after printing, it wait for 1 second. For each and every seconds, it's going to print temperature and humidity on a console. So this is about temperature humidity sensor interfacing. Okay, all right, so we are clear with the temperature humidity sensor. We'll move forward. Also, we can use different softwares for data logger. So as you know that interfacing of a sensor is not sufficient, so we require to capture the data and we need to record the data as well. So there is a software known as an PLX data DAC, that is PLX DAC data logger. So you can download it from a free. So again, this software is open source, and this is integrated with Excel, Microsoft Windows, Microsoft Excel, and Excel is having the facility to load all the data row wise. So we can have a column headings, and we can enter each data on a different row as a data logger. Okay, so for that we need to do some settings. So Excel settings, I have given a snapshot of Excel settings. So we need to open Excel options. So in a menu bar, we have Excel options. From that, we need to go to a customize ribbon bar, and under the customize ribbon, we need to enable this developer option. So whenever you enable this developer option, so you will get these particular options available like code, add-on, control, XML, and modify. So these options are enabled only when you enable this developer option. How to enable this, I will show you. Just discard the things, and I will open a Excel. So here it is, my Excel available. So once I open the Excel, so I will open a blank Excel sheet. So I have already enabled this developer option. So I have here developer options. So how you can enable that? Go to the options here from a menu. So I need to click on a file, go to options. Okay, once you open these options, we have a customized ribbon bar available. So click on that customized ribbon bar, and here it is a developer option. So if I untick this developer option, and you can observe that the developer tab has been gone. So there is no developer tab available on the top headings. So to enable that developer tab, so again I have to go to the file, go to options, go to customize ribbon, and then enable this particular developers tab. So once you enable, all the things will be enabled like code, add-ons, control, and XML will be enabled. Okay, also you can enable or disable many of the controls available with Excel. Also you can change it here from this. So Excel is very powerful tool, and it is most rapidly used for data analytics, machine learning as well. So for analysis of a data, the Excel is very powerful and handy tool. All right. So like this way we can enable a developer option. After enabling the developer options, we need to go to a macro settings. So macro settings are available under a developer options. So we need to enable those macro settings as well. So enable all the macros, not recommended, potentially dangerous for code run. So we need to run the code as well. That's why we need to enable the macro settings. And again, we need to take care of which code you are running, because there are chances of getting a virus or some malwares through that particular code, and your data of Excel getting corrupted. Okay, so we need to take care of which type of code you are running under that particular macro. So like this is the front window of PLX stack. Once you install this PLX stack, so you'll get this control options. So here we can connect the port and we can set the baud rate. Then there are the buttons available like connect, reset timer, clear timer, download data, clear data, user 1, user 2. You can set with the user and we'll have here a data. So whatever you are writing in a code, that will be wrapped under this particular Excel. So where you will get this PLX stack, for that there is a website. So like this data will be available. So I have just logged temperature or voltages. So those voltages are logged, and with the second, which every millisecond it's going to log the data. Okay. So from where you will get this particular thing? For that we need to open a browser and type PLX DAC on the browser. So I will show you that. Just open a browser and go to google.com, and in that PLX DAC, just type PLX DAC. Once you type PLX DAC, this is from Parallax. So just click on PLX DAC link. So here you can directly redirect to a download option. So PLX DAC zip is available. That is 1.96 MB software only. So this software is developed very early, that is under 2014, and we have PLX DAC release 2B. Beta release is also available. So you can download that beta release as well. So here you can go to download a beta release. So I have downloaded the beta release, and you can interface that with Microsoft Office or Excel 2002 2003. It may not work for newer software, no longer supported for that. So it is open source and they have not supporting the newer versions of PLX DAC, but for 2003 or 2000 Windows Excel 2000 it's going to support. Okay, so like this we can download the PLX DAC. All right, so we'll move forward. So this is like this way you will get a data onto the PLX DAC. Next type of a sensor we are going to look for is a gas sensor. So gas sensor is very important to detect the gas or natural gases or any different type of gases like methane, benzene, alcohol. So for that purpose the gas sensor is used. Okay, so gas sensor is used for detecting various gases. So explosive gases such as propane, toxic gases such as carbon monoxides or air quality sensors, and volatile organic compounds that are responsible for sick house syndrome. So we need to detect the gases, and for detecting the gases, so there are different types of gas sensors available in the market. First type of a sensor is MOS type of a gas sensor. Second is catalytic type of a gas sensor. Third is electrochemical type of gas sensor, and fourth is NDIR, that is optical type of a gas sensor. So we'll see what are the differences between MOS type of a gas sensor, catalytic type gas sensor, electrochemical type gas sensor, and NDIR type gas sensor. So we'll see first MOS type gas sensor. So what is there in the MOS type gas sensor? So here MOS type of gas sensor, clean air or a donor electron in tin dioxide are attached towards the oxygen, which is absorbed on the surface of the sensing material, preventing electric current flow. Okay. In this presence reducing gases, the surface density of absorbed electron decreases as they react with the reducing gases. The electrons are released into the dioxide, and it allows the current flow freely through the sensor. So here is a diagram for MOS type of a gas sensor. So we have combustible gas So whenever there is a clean air, so no, and whenever there is oxygen part is been taken care by the combustive air, and due to this the conductivity goes on decreasing. Okay, so based on that conductivity, we are going to measure the amount of combustible gas is present inside the air. Okay, so like this the uh, sorry like this the MOS type of a gas sensor works. So there is a tin dioxide layer, and that tin dioxide layer with interface with the oxygen part, and that oxygen part will be taken care by the combustible gas, and due to that it's we have heater here as a element, and we have a dry cell as well. So it whenever there are the gases, then the light glows like the resistance. Whenever there is a clean air, no light will glow. Okay, so it depends on the conductivity of this particular thing. Okay, so next thing is we'll move forward. Next is catalytic type of a gas sensor. So under a catalytic type of a gas sensor, there are two elements. One is a detector element and another is a compensator element. So there are two elements available for this particular catalytic type of a gas sensor. So there are two elements available. One is a detector element which contains the catalytic material and the sensitive to a combustible gases, and a compensator material which is having inert. So combustible gases will burn only the detector element. So the combustible gases, which are the combustible gases are there, those are burn only a detector element, causing rise in the temperature, and the consequences rise in the resistance as well. So this is also dependent on the resistance base factor. So as the combustible gases comes into a picture, and with the detector element it burns out. The combustible gases will not burn the compensatory element. So there are two elements available. One is a detector element, another is a compensatory element. So combustible gases will not burn the compensatory element, and thus the temperature and the resistance remains unchanged, and we'll have just constant resistance of that. So how it looks like, I will show you the figure. So here we have two elements. One is a, here it is a compensatory element, and we have here a detector element. So whenever there is a clean air, no heat will be generated, no resistance will change. Whenever there is a like combustible gas, or whenever the gas is present, at that time it changes the detector element and the heat gets produced. Okay, because of the heat, it increases the resistance. So the voltage divider diagram will get. So we have a constant resistance, and we have variable resistance, and V out will be changed. Due to the V out change, that is here it is a C type, that is condenser type element, and detector type element. So we have condenser and detector type element. Due to the change in that particular air composition, the variable resistance will change, and this is proportional to the gas concentration. Okay, so variable resistance, that resistance is proportional to the gas concentration. So just we form a voltage divider network to get the proportion of what type of gases present there. Okay, so we have here normally a Wheatstone bridge circuit to be formed with both the element. A variable resistance VR is adjusted to maintain the state of balance of the bridge circuit in a clean air form combustible gases. When the combustible gases are present, only the resistance of the detector element will rise, causing an imbalance of the bridge circuit, thus producing the output voltage signal V out. Okay, the output voltage signal is proportional to the concentration of combustible gases. Okay, that's why we'll get whether which type of gases are present inside normal air. Okay, so like this we'll have catalytic type of a gas sensor. Next is electrochemical type of a gas sensor. So we have electrochemical gas type of gas sensor. We have sensors are aromatic fuel cells with two electrodes. So they have fuel cells, and it's having two electrodes. One is a working electrode and another is a counter electrode. Okay, working electrode is available and counter electrode is available. So ion conductor is there, H plus can move. Okay, due to the compositions available in the air, this H plus will move, concentration of H plus will change, and we have ion conductor and solid or a liquid, both the types they uses. Here in the carbon monoxide presence, what will happen? The H plus will change, or H plus will move somewhere, and it will detect this particular thing. Okay, and thus it generates the electricity, or it generates some potential difference. So E plus and E minus, and the deflector will shows the current. Okay. The basic component of two electrode gas sensors are working, sensing electrode and a counter electrode, and the ion conductor in between them. So we have ion conductor, and we have counter electrode and a sensing electrode. That is working electrode and counter electrode. Okay. So this is about electrochemical type of a gas sensor. Next is NDIR type of a gas sensor. So it is basically uses infrared light, is absorbed by the gas molecules at the particular wavelength. So this uses infrared light. So it is basically a light type of a gas sensor. It uses infrared light, is absorbed for the gas molecule at the particular wavelength. Okay, causing the vibration of the gas molecules. NDIR stands for, NDIR long form is non-dispersive infrared. Okay, NDIR long form is non-dispersive infrared gas sensor. Non-dispersive infrared gas sensors. These are used to detect the decrease in transmitted infrared light, which is in a proportion of a gas concentration. So this non-dispersive infrared gas sensors are used to detect the decreased in transmitted infrared light, which is in proportion with the gas concentration. This transmittance, the ratio of transmitted radiation energy to the incident energy, is dependent on the target of the gas concentration. So how it looks like, I will show you the diagram. So here we have a clean air. So this is, here it is a transmitter source. We have a LED source available, and we have here a photo element or a detector element, so which detects the light energy, and we have a window. From this window the gas will pass. Okay, so in terms of a clean air, the light transmitted by the light source is a constant one. There is no change in the light in infrared light. So detector element will receive the same light at the destination, but whenever there is a some gas concentration available inside this window or inside this vicinity, suppose in a carbon dioxide is available in that particular vicinity, then what will happen? This light source will emit the light, but that light is not constant at the receiver end. So there is some proportion of a light will change, and that proportion is dependent on the gas concentration. So we can have a formulation, or we can have some equation. That equation will give you the data of gas present in that particular air. So this is about NDIR type of a gas sensor. Okay, details about the NDIR, that is non-dispersive infrared gas sensor. So we have NDIR gas sensor consists of an infrared source, as we have seen. We have a detector inside it. Then also it uses optical filter and a gas cell and the electronics for a signal processing. Okay, so there are some components available for this particular signal processor and detecting. A single light source with a dual wavelength type of a gas sensor has two detectors with two optical filters and a different wavelengths, which are placed in front of each detector. So we have two detectors available, and two detectors are placed in front of two light sources. Okay, the infrared light that is absorbed by a target gas passes through the active filter. So there is an active filter is used with a particular bandwidth for the detection of a target gas as well. Okay, the difference between transmitted light, so as I have already explained, the change of the transmitted light will be there when there is a gas is present. Intensities in this two bandwidths is converted into gas concentration. So like I have just explained, in this case, whenever there is a no gas present, so same amount of a transmitted light will present on the both the detectors. But in case of a gas is present and that particular thing, the amount of intensity received at one detector is changes, and on the another side detector the amount of intensity will be different. So based on the difference of the amount of intensity, it tells amount of concentration of the gas present in that particular air. Okay, so this is like about how to detect the amount of intensity in the gas sensor. Okay, so this is about the amount of intensity and the gas sensor. Okay, Now we have in the market, we have MQ series of gas sensors. So MQ series is very popular gas sensor series available in the market, and with a very low cost you will get MQ series gas sensors in the market. So what it contains, MQ series gas sensors uses a small heater inside it. So it's having a small heater element inside it with an electrochemical sensor. So it is basically electrochemical type of gas sensor. So like we have seen this type of a gas sensor. So this type electrochemical type of gas sensor. So we have conductor element in that, that is ion conductor element. We have working electrode and a counter electrode available, and then there is a deflection. Okay, and because of the H plus, that is H plus moving, it changes the gas concentration, or it detects the gas concentration. So like we have, they are sensitive to the range of gases and used for indoor room temperature. So these gas sensor MQ series are used in the indoor room temperature and indoor gas detection. They can be calibrated more or less using the load resistance or burning resistance, but no, the concentration of measured gases or gases is known to be that. The output of this particular MQ series is analogous in nature. So it will give you the analog output, and that analog output we can read it over the analog input of the Arduino. So you can use analog input of the Arduino, and you can read that particular analog output from the gas sensors. So while connecting this MQ series of gas sensors with a Raspberry Pi, you need to use ADC hat on the Raspberry Pi, because a Raspberry Pi is not having ADC inside it. So we need to use the ADC hat for the Raspberry Pi as well. Okay, so here it is an internal construction of MQ series of gas sensor. So here this is a diagram of MQ series gas sensors. So we have the connect element A and B. So these A and B elements are shorted. So all the things are shorted, like this A is shorted with A. There are total 6 pins. So this A and this B are shorted. Okay, both A and B are put together. All right, pins together, and we have EH, that is a heater element. So there are two heater pins, 1 and 2. There are 6 elements and 6 pins available. So as I told, all the A and B are shorted, and we'll have only 2 pins for that. Here it is a and here it is a pin number B, pin B. Then we have here heater coil. So H is there and H is there, and the coil is inside. Okay, so like this, the variable resistors in the picture is a load resistance. It can be used to determine the good value, and a fixed resistors for the load resistor is can be used in most of the cases. The voltage of the internal heater is very important in this case. Okay, the voltage of internal heater will change due to the gas concentration, due to the H plus movements. So here these are the H plus movements. So based on that H plus movement, this voltage will change between this particular two plates, and this is working electrode and the counter electrode. So this voltage will change, and that voltage is detected here. Okay, so here it is a connection diagram. So we have here VCC supply given to the B and A. So A and B are shorted, and we are giving A or B connection pin. Also the second pin A or B we are taking as an output, and we have attached one register for that as well. And we have a heater coil, so H and AH, and this heater coil is exposed to the gas. So based on the gas concentration, it detects the amount of gas present in the air. Okay, so there are different gas MQ series sensors available, so to detect different concentration of gases, and they have numbered like this. So just note down this particular numbers. So we have MQ2 series. So MQ2 is there for detecting methane, butane and LPG smoke. So for detecting methane, butane, LPG and a smoke, this MQ2 sensor is used, and heater voltage is a 5 volt for this particular MQ2 sensor. Okay, then we have MQ3 as a sensor, and MQ3 is used for detecting alcohol, ethanol and the smoke again. Okay, and the operating heater voltage is again 5 volt. Then we have MQ4 sensor. MQ4 is a number for the sensor which is used to detection of methane and CNG gases. So MQ4 is used to detect especially CNG gases, and again the heater voltage is 5 volt. MQ5 is again a sensor. MQ5 is used for detecting natural gas or LPG. Again MQ6 can be used to detect this as well, MQ6 is there to detect LPG or a butane gas. Okay, with operating voltage is a 5 volt again for both the things. MQ7 is used for detecting carbon monoxide. The operating voltage is alternative, that is 5 volt to a 1.44 volt. MQ8 is there to detect the hydrogen gas. This is a costly sensor to detect the hydrogen gas, and operating voltage is a 5 volt again. MQ9 is there which is used for detecting carbon monoxide and flammable gases. Alternate voltage is 1.5 volt or a 5 volt. Okay. Then we have MQ131 which is going to detect the ozone gas, and operating voltage level is a 6 volt. We have MQ135. So MQ135 is a air quality sensor. It is named as a air quality sensor, which is a combination of benzene, alcohol and smoke. So it's going to detect the benzene level, alcohol level and a smoke level in the air. So operating voltage level is again 5 volt. Then we have MQ136 again which used hydrogen sulfide gases, which used to measure the hydrogen sulfide gases, and operating voltage level is a 5 volt. MQ137 is there, so which is used to detect the ammonia in the gas, and operating voltage level is a 5 volt. MQ138 is there, which is used to detect benzene, toluene, alcohol, acetone, then we have propane, then formaldehyde gas and a hydrogen. So again this benzene, formaldehyde gas, so this is again used, and the operating voltage level is again a 5 volt. Okay. Then we have MQ1214. This is specifically used for methane and a natural gas. Operating voltage level is a 6 volt. MQ216, again it is used for natural gas and a coal gas. MQ126 is used for natural gas and a coal gas. The operating voltage level is a 5 volt again. MQ303A, so it is used for alcohol, ethanol and a smoke. Operating voltage level is a 0.9 volt for the heater. MQ306A, LPG and a butane gas. Operating voltage level is a 0.9 volt. MQ307A, it is used for carbon monoxide, and the operating voltage level is alternative, that is 0.2 volt and 0.9 volt. Then MQ309 is the gas sensor again, which is used for carbon monoxide and flammable gases. Okay, this is used for carbon monoxide and flammable gases. Operating voltage level is 0.2 volt to 9.9 volt. Then we have MG8111, that is carbon dioxide CO2 sensor. Operating voltage level is 6 volt, and MQ, that is AQ104 or MQ135, both are air quality sensors. So again AQ104, it is a air quality sensor. Operating voltage level is 5 volt again. So this is about different types of MQ series gas sensors. So you are going to use this particular gas sensors for detecting different gases present in the air. Okay, so we'll end up the lecture session here for the today's session. So I will be here for next 5 minutes for question answers. So those who have any question answers, then they can type in the chat box for this. I will answer those particular questions in the chat box. So again, those who are not subscribed my channel, please hit the subscribe button for next upcoming updates. So we'll stop here for the session, and we'll see on the chat box for next question and answers. Okay, thank you for listening. Thank you.